Very good morning, dear students. In this video, we will discuss about DC network analysis. So, I have selected the topic network theorems by Muniraja D K, the Department of Physics. Network theorem. The first, we will start discussing about electrical network. What is the electrical network? The electrical network is the interconnection of the batteries, resistor, capacitor, inductors. Is called as electrical network. In this diagram, you can see clearly the battery, resistor, capacitors, and inductors are connected internally. This interconnection of these electrical components is called as electrical network. So the definition is an electrical network is the interconnection of electrical components. Example, battery, resistor, inductor, capacitors, switches are called electrical network. Next one, circuit. Network terminology is under that circuit. A circuit is a closed path containing a source of EMF, resistor or an inductor or capacitor, or a combination of two or more of these elements are called an electrical circuit. There are two types in electrical circuit: linear circuit and non-linear circuit. A linear circuit is one whose parameters are constant, that means they do not change with current or voltage. A linear circuit is one whose parameters are constant, do not change with current or voltage. What is the meaning of this? That means the relation between the input and output is linear. That means let us consider the simple circuit which has a variable voltage source, so, and a resistor which offers 5 ohm resistance to flow of current through it. If you vary the voltage and note down the current through the resistor and find the ratio of V by I, that gives a resistance, because V is equal to IR, R is equal to V by I. So for different values of voltage, what's the current through the resistor, you know down, find the ratio. The ratio gives the resistor for different values of applied voltage and current will be same. So that means the resistance value does not change. You will get the same value of R is equal to 5 ohm. Different values you will get current and voltage. Each value of voltage you will get some current value. If we take a ratio, you will get I by V is equal to IR. V by I is equal to R. So you will get R is equal to 5 ohms. So second value V1 I2, V1 I1, V2 I2. So V2 by I2, 5 ohm. So it is independent of the value or what is the characteristic of the circuit element, that is resistor. It should offer 5 ohm. So with applied voltage and current, the characteristic of that circuit elements does not change. That is, parameters does not change. Those parameters of circuit elements are independent of applied voltage and current. Such a circuits are called linear circuits. Next one is non-linear circuit. So non-linear circuit is one whose parameter changes with applied current or voltage. Such a circuits are called non-linear circuits. Non-linear circuits. Next one is bilateral circuit and unilateral circuit. So we will discuss about bilateral circuit. Next we will discuss about unilateral circuits. Bilateral circuit. Bilateral. So bilateral circuit, which let us consider first bilateral circuit elements. So bilateral circuit elements are those circuit elements which allow the electrical current in both the direction. Example, resistor, capacitor, and non-polar capacitor and inductor. Resistor. In the resistor there is no polarities. We can pass the current in any both the direction. But value of resistance cannot be changed. Suppose the resistor offered 100 ohm. If you pass the current in any of the direction, those in that 100 ohm resistance, that value of 100 ohm resistance will not change. It offers 100 ohm itself. If the current is passed in any of the direction, both the direction, even capacitor, inductor also. The capacitor, there are two types of capacitors, are polar and non-polar. Let us consider non-polar capacitor. So those circuit elements are called bilateral circuit. elements. Let us take a bilateral circuit. In a bilateral circuit, the characteristic of a circuit elements are independent of direction of current in that circuit element. A bilateral circuit. In a bilateral circuit, the characteristics of a circuit elements are independent of the direction of current in the circuit elements. So we have the circuit element. Let us consider circuit element resistor. We have a R1. So the current is passed in this direction. So second, in the same resistor, the current is passed in opposite direction. So this in both the cases that it offers the same resistor R1 when the current is passed in this direction. So it offers resistance R2, it passes in this direction. So R1 is equal to R2. What it indicates that the value of the characteristic of the circuit element is it resistor. What it offers resistance R1 R2 are same. That means that value or characteristic of the circuit elements is independent of direction of current flow. Such a circuits are called bilateral circuits. Bilateral circuits. What is the unilateral circuits? The unilateral circuit are those circuit elements which allows the current only in one direction. Otherwise, the unilateral circuit are those circuits which the characteristics of circuit elements are dependent of direction of current flow. Example, the circuit which consisting of a diode or a transistor, such as circuits are called unilateral circuit because the diode or transistor allow an electrical current only in one direction, in unidirection. It not allows both the direction. If we take a diode, it allows current only in forward direction. In reverse direction, it does not allows. It is forward biasing. Reverse biasing in the case it does not allows. So such a circuits are called unilateral circuit. Next one is active elements and passive elements. The active elements are electric generators, source of EMF, batteries are called active elements. So active elements which are supply the electrical energy to the circuit is called as active elements. The passive elements resistors, capacitors, inductors are called passive elements. The passive elements, those elements receives electrical energy from the active elements, then converts into heat energy or store it in electrical or magnetic field is called as passive elements. The passive elements and active elements. You can see this table here in the slide. Passive element resistors, capacitors, inductors. Active elements generators, batteries, amplifiers. These are the active elements which supplies the electrical energy to circuit. The passive elements resistor, capacitor, inductors receives the energy from active elements. So active elements transistor, diode, LED, photodiode, integrated circuit along with generator, source of EMF, or other means battery, operation amplifier. So what are the passive elements? Resistor, it absorbs the energy from active elements, converts into heat energy. LDR, transistor, capacitor, it stores the finite amount of electrical energy in electric field. Inductor, it receives energy from active elements and stores finite amount of energy in magnetic field. So active elements and passive elements. Circuit elements are two types. One is active elements and passive elements. Active elements are which gives supplies the energy to the passive elements. Passive elements which absorbs the energy and convert into different forms. I mean resistor absorbs the energy from the active element, convert it into heat energy. Capacitor stores the finite amount of energy in electric field. Inductor receives energy from active elements and stores it in magnetic field. Mesh or a loop. A closed path in a network is called mesh or a loop. So we can see the diagram. In this we have a network. It has a source of EMF E, R1, R2, R3, R4 are interconnected. So in this one we can see that ER1, R2, 1 loop is a loop 1 or mesh 1. This is loop 2 and one more loop is there. The loop including loop 1, loop 2, it along with this node point R2 is called loop 3, but loop 1 and loop 2, this is may called as mesh 1, mesh 2, but loop 3 is there, no, should not be a mesh. So there is a loop is a closed path with no node passed more than once. That means this is also we may consider loop 3 also we can include this R2. Including loop 1, loop 2 we may call it as mesh. That means you have given here loop 3 we may call it as. But mesh means it should not be, does not contain any other loop within it, purely a closed path, should not contain any other loop. This is called a mesh. There is a slight difference between, you must know, loop or mesh are both are same, but only some cases loop may consisting of at least only one, more should only one node, should not contain more than once one loop. Okay. Next, node or a junction. Node is a point in a network where two or more branches are joined. So node, we have a source of EMF V1, R1, R2, R3, and V2 are connected in such a way as shown in the diagram. But in this we can see that node, but don't get confused, node, junction, node. Both node and junction both are same. So just a point where two or more branches are meet together in a electrical network is called a node or a junction. Okay, dear student, I will stop it this explanation here. Next video we will discuss about Kirchhoff's current law and voltage law, then various network theorems. Okay, dear students, thank you very much by listening this video and give your valuable feedback. If you have any queries regarding this topic, you can ask me through my WhatsApp number. Already you must know my WhatsApp number, otherwise in the group you can post your question. I will clarify your question, your doubts or queries. Thank you once again by listening this video, dear students.